Live. Cool. All right. So welcome to day 2 of the engineering workshop, or for some of y'all joining in today, day 1 of the OCP summit. I'm your host, Carlos, co-chair of the OCP networking group. My partner in crime is running late. He's busy signing autographs after giving the project update a couple hours ago, but he'll be down here momentarily. So what we're going to do is we're actually going to get things rolling. For those that are participating remotely, we are on the IRC chat group. It's called OCP-networking on the Freenode server. So that's the official OCP networking IRC group. So please join. You'll be able to ask questions via there. And now, our first talk, I'd like to turn it over to Adam and Simon, talking about FBOSS and OpenNSL. So.
Hi, I'm Adam Simpkins. I'm a software engineer at Facebook, working on FBOSS on our network engineering team. And so we're really happy to have announced FBOSS is open source today and put up the agent code on GitHub. And I figured we'd talk a little bit about like what is FBOSS, what's available, how to use it, that sort of stuff. Because we've announced FBOSS in the past, a while ago, before it was open source, and there's been a lot of press about it, but questions of what exactly is it. So I figured I'd talk first about like what exactly is FBOSS. I'm sure you guys have already heard by now of Wedge and 6-pack. Wedge is our top-of-rack hardware, which we contributed the spec to OCP today. 6-pack is our 128-port by 40 gig sort of chassis switch. And so having open hardware is great. It's great to be able to go buy this hardware, but what's going to run on it? So FBOSS is the software stack that we run on top of Wedge's 6-pack at Facebook. And FBOSS is basically a software stack for a switch design for Facebook. We're really excited about moving the industry forwards and making it open source and contributing, collaborating with the community to see what sort of software can be built for switches. But first and foremost, FBOSS is a software designed for Facebook data centers. And just to give a little overview of like what FBOSS looks like inside of it. Despite having OS at the end of the name, sort of like a lot of other switch software that runs on third-party vendor switches, despite having OS in the name, FBOSS is not actually a full operating system. Really think of it more as a series of user-space applications that run on top of Linux. So it's a standard Linux distribution that we use on top of our Wedge switches. We happen to run CentOS, but the FBOSS code itself doesn't really care what distribution it runs on top. As long as you've got a kernel and standard user-space libraries, libc, that sort of thing, you can build FBOSS and run FBOSS on it. So we've got a standard kernel, we've got all sorts of standard system tools and libraries, configuration management, monitoring daemons. All this stuff looks like a server for us at Facebook. So this is all the standard stuff that we run on all of our servers. The main pieces of FBOSS there is OpenNSL, which controls the tried porting ASIC in the Wedge switch. And then an FBOSS agent, which is our user-space application that links in against OpenNSL, and then it programs the porting and routing entries in the ASIC. And then the other piece for us is this routing daemon. So we use BGP primarily in our network, and so we have a whole simple routing daemon that talks BGP, learns all the routes, and then programs those into the agent via Thrift APIs. We're really big fans of Thrift. At Facebook, this is an RTP protocol we use to talk to most of our services. And so internally inside the switch, we use Thrift to talk to a number of our processes for inter-process communication for us. And on the right-hand side, you see OpenMC as well. So we open source OpenMC today. It's a separate Linux stack that runs on the board management controller. Board management controller is a small system on a chip, which handles band control, temperature sensors, a lot of platform management functionality. And a lot of people have questions about SDN, and SDN is a very popular term these days. How does FBOSS fit into the world of SDN? And just to sort of give a recap, I mean, SDN means a lot of different things to different people, but typically what people talk about when they talk about SDN, this, even though I've got SDN on the top right there, this is more sort of traditional routing network that people are used to, where they've got a bunch of switches. All the switches, run routing protocols and manage the hardware. It's all isolated in each switch. What most people mean when they talk about SDN is you take all that routing logic out of the switch, you centralize it in a controller somewhere, and now your controller does all the routing. All of your switches, run some sort of agent, typically OpenFlow, what people talk about when they talk about SDN these days. So this is sort of traditional SDN. The switches are very simple and dumb. They run this sort of agent controlled hardware, and a lot of routing logic is centralized. This is not quite how we use it at Facebook. At Facebook, our model, I like to call it more of a hybrid SDN. So we don't pull all the logic off the switches. We still have a lot of intelligence on the switch. The switch still does most of the routing decisions for us. But we do have a number of controllers. It's not just one controller, it's a number of controllers specialized for certain applications. So we'll have some controllers that are specialized for, controlling bandwidth. If we've got sort of large elephant flows and some, database replications and copies, we've got controllers that sort of figure out how much bandwidth is available and shape traffic for that. We've got controllers that do some source-based routing. So we have a handful of more specialized controllers. And in our case, a lot of those controllers talk directly to servers rather than talking to network switches. We're pretty lucky in that we control not only the switches, but also all the servers and applications in our network. And so our SDN controllers can talk directly to the servers. And this gives us a lot of flexibility because some of these things like rate limiting, it's a lot easier to do this on the servers than on the switches, and you can do a lot more powerful things there. So I want to talk briefly about why we want to build FWAS. I'm not going to go through all of these bullet points. There's a lot of reasons why we think a custom solution delivers better value for us. But the one bullet point on there that I did want to talk about is sort of moving the industry forward and helping foster innovation. We think there's a lot of value for us in building FWAS for our data center and having better automation and better monitoring and just in general integrating into our environment better. But we're also really excited to be able to open source it and provide FWAS as an example of here's how a switch can be built, here's how it can be customized for your environment, and here's code that you can take and leverage for your environment. And we're really excited to see sort of where the OCP community takes this and what other sort of innovations other people build that we can also leverage and bring back into our environments. Of course, when I talk to people about the stuff that we build and this project that I work on, one of the first questions I get is, gee, that sounds really hard. I mean, there's lots of other companies out there that have thousands of developers dedicated just on building switches. Why would you go want to build this yourselves? And I guess the point I want to make today is it's really not all that complicated and not that daunting. So all the stuff that I'm talking about here today, we've built FWAS and OpenBMC with a pretty small team. So we started out with 2 developers on the team. I think now the team has grown to like 7.5 or 8 developers. And of those 8 developers, 1 just joined within the last 2 weeks. One of them joined 2 months ago, as most have been working on the open source release. 2 of them have been dedicated to OpenBMC. And so the actual work on sort of the FWAS agent and our routing protocol daemon and a lot of the tooling around it, that can be done with a relatively small team. And there are a couple things that make this a lot easier for us than if you look at sort of traditional switch solutions. So FWAS, it's a custom switch designed just for Facebook. We don't have to build a generic switch that you can take in any environment, and it's infinitely configurable that you can run in an OSPF network, or if you have ISIS, or we don't have to support a large feature set, and we don't have to support a different configuration matrix. We have one use case, and that's the Facebook data center, and we can build just for that. And we can make sure the features work really well in that environment, and we don't have to test any other configurations beyond that. And because we control our network, it's a very small feature set. There's not actually a lot of work and a lot of things for us to build. And it leverages a lot of our existing infrastructure. This is one of the main goals for us with Wedge, is making Wedge look like a server. is that we can take all of the tools that our server team has built, because we've got a really great team managing our servers. We've got lots and lots of servers, way more servers than switches. And we already have really good tools about how to automate those. And in the networking world, our automation has always been a little hacky, just because we're working with third-party switches. They're not always designed for automation. They're designed more for humans to interact with. And so the automation has to be rebuilt for each different type of switch, and it's just never been as good as our servers. So we wanted to be able to leverage all of our existing server automation tools. So talking about sort of the small feature set, when you look at our top of rack switch, this is sort of the environment around the top of rack switch. So you've got our wedge switch. It's got a bunch of ports connected directly to servers inside this rack. And then it typically has 4 uplinks, maybe a little more for us. And this is pretty much it. That's all there is for us. This is a layer 3 router for us. So the servers are all in one subnet. And then we've got a sort of a peer-to-peer /127 subnet for the uplinks. And really, this is it. It's a very simple network. We don't do things like multicast. We don't support spanning tree here, because all we've got is like one VLAN for servers. We don't do fancy L2 overlays. So it's a really small feature set. So if you look at sort of what are the protocols you would need to build a switch that works in this environment, it's not a very long list. So first off, you need neighbor discovery protocol, so that your servers in the rack can figure out like what's the MAC address of my gateway. Although actually we might soon be moving away to just sort of static configuration. There's some reasons for some clients it's just easier to be like, I always know the router is this fixed link local address. But we need neighbor discovery protocol. We're rapidly moving towards a v6 only environment in our data centers, but we still have IPv4 in a lot of places. So you need ARP for IPv4, provide the equivalent functionality of neighbor discovery protocol for IPv4. So you need ARP. All of the routing in our network is controlled by BGP, so you need BGP as well. But you don't even need a full BGP implementation. So one of the pieces that isn't open sourced in our initial release today is our routing protocol daemon. We're using a homegrown daemon at the moment. We're not using any open source routing daemons, although there are a number of those. But it's custom built, it's just for our environment, and we only build the pieces of BGP that we actually need in our environment. It's a pretty small feature set of being able to announce the route for our subnet, and then receive routes from our uplinks. And if we stop here, this actually gets you pretty functional. We went ahead and deployed switches in our data center when we just had this feature set available. And by and large, you can do a lot of stuff with just these 3 protocols. There are a couple things that you really should also have. I mean, ICMP, you really want to be able to like do traceroute and actually have it work. You want to be able to support some ICMP functionality of send back, TTL expired, and that sort of stuff. So you want some ICMP. There's some other things that are useful, like LLDP. LLDP is really nice to be able to tell, like, oh, at the data center when people are provisioning new switches, did the cables get plugged into the right ports and whatnot. But by and large, this is the full list for us of protocols that we need in our data center. So it's not a very long list, and it actually can be built relatively easily. And the other piece that I mentioned before is we are able to leverage a lot of our server tools. If you look at this picture here, most of it is existing tools that we were able to take from our existing stacks. So the only pieces that were built specifically for FBOSS are basically that routing protocol daemon and the FBOSS agent. Now, I do have OpenBMC here on the right-hand side. We did end up building that ourselves, but we're transitioning that work to our server team, and we're starting to leverage that to leverage OpenBMC and future server platforms as well. So if you look at the feature set, if you're able to take an existing server and just pretend you had a server that all of a sudden you put a forwarding ASIC in it, it's not a lot of extra functionality that you need to implement a basic layer 3 switch. So there's a couple other things that really make this a lot easier for us than if you're looking at traditional switching companies. we're able to have a really fast development cycle. And a lot of this is because developers have direct access to the production environment, and we iterate on code really rapidly. So I don't know if you've read much about Facebook's engineering practices a lot before, but we're really big on sort of continuous deployments. Or maybe not quite continuous, but you know, for our website, we push the code every week. And for most of our backend services, we push code every week. And so that was, you know, very important for us when we were starting the FBOSS project. We want to make sure we can push code to our switches every week. And so we spent a lot of effort in making sure we can do this sort of graceful, non-disruptive code updates every week. And this is really important because, you know, it can be a little scary pushing new code every week because you're like, maybe I'm pushing a bug every week. But at the same time, if you look at sort of traditional release cycles, or if I'm going to do a release cycle every 6 months or every year, yes, you don't have to pay the pain of releases very often, but each time you do it, it's a lot scarier. If you've got code that hasn't been tested in production for, you know, 6 months or however long, you know, when our weekly releases, it's a smaller delta each time. And we have a lot of good practices in place where you deploy to a handful of switches, you let it run for several days. And typically those switches, we know if it fails and something blows up, it's not a big deal to lose those racks. And we get really good monitoring and stats out of those. And so our deployment process is every Monday we cut a new build, we deploy to a number of switches. By Wednesday we have pretty good confidence in it, and then we roll it out to all the rest of the fleet. So this is really important to let us develop code very quickly, get new feature sets, and get them tested to make sure they're really working well and stable in production. So the other piece that I think is really important for us, and I always advocate inside Facebook, is making sure that development and production are always really close together. We tend to try and unify our development teams and our operation teams. We do have sort of, there is internally a distinction between sort of software engineers and production engineers, but it's a very slight distinction. They all work together, they all do roughly the same things, and they collaborate very closely together. And it's very important for us that you make sure your developers are responsible for making sure that the code runs well in production, are responsible for doing your pushes, and are part of your on-call rotation. You know, developers can sort of push back against this sometimes because as a developer, it's a pain to be in the on-call rotation and having to deal with, you know, bugs and issues like that. But it's really important because when your developers feel the pain from bugs, they have a much better sense of which bugs are high priority and getting those bugs fixed sooner rather than later. You know, because we've had instances and cases in the past where we had the development team would write the code, and then you've got an operations team that sort of maintains it in production and deals with issues. And it's really easy in those cases to have, you know, the operations guys will be like, I know the code hangs every once in a while. Every day I'm going to go through and like find machines that are hung and restart them. Whereas if you had a developer who had to do that, they're going to be like, I'm going to go fix that hang. I'm not going to like build scripts that go and like restart stuck processes and stuff. So it's really important for us to make sure that developers are heavily invested in the operations piece and involved in deploying code in production, debugging code in production, and making sure it runs really well in production. So that's a little bit about, you know, why we can actually build FBOSS without, you know, it's not as difficult as you might think. Let me talk a little bit about what's available on GitHub today, what's going to be coming in the future, and then how you can actually sort of download and use FBOSS and try it out in your own environment. So here's the GitHub URL. The code went live this morning. You should be able to download it and build it. It does depend on a few other Facebook libraries. They're also available on GitHub. So, and just to recap, if we look at our system overview, the main piece that we open source today is this agent daemon. There will be some other stuff coming. Like I mentioned for our routing daemon is rather custom to our environment right now. So we figured it's probably not as useful to the community, just since it's very specific to our roles in our data centers. But it should be very straightforward to take an existing open source routing protocol daemon and modify it to talk to our FBOSS agent. So our FBOSS agent just exposes very simple Thrift APIs. It exposes APIs for adding routes, deleting routes, and it exposes an API to just sort of resync the fib with the routing protocol daemon. This is particularly useful in cases of managing restarts. If either your FBOSS agent restarts and you want to resync and match your state with the routing protocol daemon, or if the routing protocol daemon restarts and wants to just resync all of its state. So like I mentioned, if you go and download FBOSS today, it's a little tricky to get all the dependencies installed and working. We've got instructions, if you look, so we depend on Folly and we depend on FB Thrift. Most of our tools inside Facebook, we tend to run fairly recent versions of tools, so it does require GCC 4.8 plus. We have instructions, we have some pretty decent instructions in the FB Thrift repository and the Folly repository about how to install the dependencies for these repositories, get them all building, and get them installed on your system, particularly if you're running Ubuntu. Instructions for CentOS should be pretty similar, but they're not quite as explicit there in the documentation. The build scripts right now for FBOSS aren't super awesome, so we've got a makefile there that we're probably going to end up replacing with the CMake build system or something in the future. So the makefile there should get everything building for you, but we know it's suboptimal and doesn't really get dependencies right if you modify headers and stuff. So there will be some improvements to that, but it should be possible to get it and build it and download OpenSL from the Broadcom GitHub repository and get everything building and working. So great, so if you're able to download FBOSS and get it building, then what? What do you do with it? So our build process right now produces one main binary result, which is the FBOSS agent. I believe there's a separate agent right now that's we have two platform directories. One is for Wedge. We have one that's a simulation platform doesn't really talk to a forwarding ASIC, but it just lets you run it if you want to test something, if you have a development server that doesn't actually have a real forwarding ASIC in it. The sim agent lets you start it up without a forwarding ASIC. The sim agent is a little bit incomplete. It's mostly just used for some of our testing right now. But that is there if you happen to want to just build the code and at least try and run it without an actual switch. But there are a couple of pieces. Once you start the agent, how do you interact with it? What do you do with it? So like I mentioned, we have a Thrift file exposing all the Thrift interfaces to talk to it. The Thrift compiler, if you generate Python output for the Thrift compiler, will automatically generate a command line utility that lets you call all the Thrift functions inside a given Thrift interface file. So that's probably the easiest way to interact with the agent right now, is to generate, it's called a Python remote script. And then you can use the Python remote script to talk to the agent, query all of its Thrift APIs, add routes if you want, remove routes, that sort of stuff. We do have some better tools to do this that are a little more user-friendly than the Python remote scripts. But we didn't quite get those out in time to be part of the initial release today, but I would expect those to be coming in the next few weeks. So we will be releasing some more user-friendly, sort of command line tools to introspect the state of the agents, get details about, ARP neighbors, NDP neighbors, and port status, that sort of stuff. So all that stuff is visible through Thrift APIs today. It's just not in quite as user-friendly a way, so we'll expose a CLI tool for that coming soon. Other pieces to know about the FBOSS agent for now. So once you start running the FBOSS agent, your server normally has its own E0 interface for the local management NIC. The FBOSS agent will expose another interface called front zero. This is basically a ton interface, so it's a layer 3 interface exposed to Linux. If you have user space applications that want to send packets out the front panel port, out any of the front panel ports. So the FBOSS agent will automatically add IP addresses to that interface for any IPs listed in the FBOSS config file. So there is a configuration file that the agent needs to know about how should it configure VLANs, how should it configure interfaces, what IP should be on those interfaces. And so the FBOSS agent will then create this front zero interface, add the right IPs, and then user space applications can then send packets out the front panel port. We don't expose per port interfaces to Linux right now, just the front zero interface. This does mean right now that sort of protocols that need per-port access currently have to be implemented inside the agent itself. So right now the agent implements NDP, LDP, that sort of stuff. That's all inside the agent even. We very likely might refactor some of this in the future to be able to implement that more easily outside the agents and run some of these protocols separately as separate processes, and also expose better APIs for just sort of exposing packet capturing APIs outside via Thrift APIs. So that likely might come in future releases as we develop stuff. And so FBOSS is still undergoing heavy development inside Facebook. We're still developing, adding lots of features, refactoring things. We're still working on getting more stuff approved to be open sourced. So I would expect more things to come over the coming weeks. Like I mentioned, sort of better build system, additional management tools. There's a handful of features that didn't quite make it in the initial open source release that will be coming soon. Some of those things that didn't quite make it in yet are some of the QSFP managements, LED control, some of the LDP functionality is not quite there yet, but should be coming out pretty soon. And then just to wrap up, we're really excited to see and looking forward to see where the community goes with this. Wedge switches are available to buy, and with OpenNSL and with future things coming out of the OCP networking group like SCI, it's actually pretty straightforward to take a switch, start hacking on it, build applications that work in your network, in your environment. So whether or not people are taking FBOSS, enhancing FBOSS to work in their environments, using it as an example as a starting off point of like, hey, if I wanted to build something custom for my environment, not for Facebook's environment, how would I do that? Or just going off in totally different directions. We're really excited to see where the community takes this, what sort of innovation it drives, and we're looking forward to leveraging and seeing where all this goes. So with that, I wanted to hand it off to Simon from Broadcom to talk a little bit about OpenNSL.
Thank you, Adam. My name is Simon Lee. I'm part of the OpenNSL team at Broadcom. I've got just a short number of slides here just to give you a run through of what OpenNSL is, where you can get it from, what kind of things you can do with it. And then myself and Adam have got some time at the end when we can take some questions. So OpenNSL, it's a set of APIs that sit on top of the Broadcom SDK for Strata XGS switching. So there's probably a number of people in the room here. If you looked at OpenNSL source code, you'd recognize immediately the SDK API. You'd see the calls right in there. The reason we've done this is so that the SDK is a proprietary API. We wanted to have an API that applications like FBOSS or other applications could be built on top of and open sourced. So without OpenNSL, you would have to sit your apps on top of the SDK, and that puts a firewall immediately on any open source. So with this, just as FBOSS has done and some of the other projects I'll describe, we're trying to foster a community of innovation, a set of projects that can go ahead and start using Strata XGS silicon. It's a one-to-one mapping. OpenNSL, there's been some questions I've had asking, will it replace this control path or that control path? OpenNSL is not a control path. FBOSS is a control path. OpenNSL is a library that lets you implement control paths or implement any other features that can take advantage of Broadcom silicon. For those of you who are familiar with the SDK and you've got your development process set up around that, OpenNSL is very interchangeable. In fact, you can often have two build environments. One where you have your open source version running on OpenNSL, another where you're maybe using some more of the corner case or proprietary areas of the SDK, and you can easily swap between the two. What do we do? There's FBOSS, there's university projects, there's startups, there's major corporations, all of these types of people want to innovate quickly. They want to get their projects out there in the public domain so that the community can continue to innovate. And OpenNSL lets you do that. And some of our own projects as well. So Broadcom, you'll see out in the vendor hall, Broadcom has something called Broadview instrumentation that exposes the packet tracing and the buffer capture and the diagnostic tools that are available on Broadcom Silicon. That's exposed through OpenNSL, and another Broadcom project called Broadview Instrumentation is available on GitHub that leverages that. And even beyond that, there's multiple projects that we're working with customers incubating on getting that up on NSL. There's SCI, there's all kinds of stuff. So FBOSS, obviously, the SCI implementation, friends at Microsoft and Dell and Mellanox, you'll be able, I think in this session you'll hear a discussion on that. Using OpenNSL as the southbound interface on Broadcom SCI implementation means that we can, at some point, open source that SAI code so that then the various control paths sit on top of that. Broadview instrumentation I've spoken about. If you go into the hackathon now, you can use the OpenNSL APIs to actually hack some applications. You can do that on wedge hardware, you can do it on interface masters hardware. If any of you have Broadcom reference designs, the SDKs, those beautiful red loud boxes, you can run OpenNSL on that using the GitHub version. What does it let you do? There's two versions of OpenNSL if you go to GitHub. And the major part of the OpenNSL version indicates what the underlying SDK version is. So what we're using on FBOSS is an SDK 6.3 release. There's also a 6.4 release out there on GitHub that lets you see some of the Broadview instrumentation APIs. But on each version, there's basic error handling with offered layer 2, layer 3. Obviously, packet RX and TX, you've got to be able to send stuff and receive stuff. Port management, spanning tree, although it wasn't used in FBOSS, stats, VLANs, and the instrumentation APIs. This is what you can get today if you go down and download it from GitHub. We're adding to this set as we continue to implement SCI, as we add new projects that are leveraging OpenNSL. We'll continue to expand this set, and almost always our goal is to make it one-to-one with the SDK. But to be open with you, there's areas of the SDK that are exposing too much IP in what's happening underneath in the silicon, and in those areas, we'll put another layer on top of the SDK that lets us expose that same functionality, so it lets you use it, but use it without seeing some of the details about what's sitting underneath in terms of the silicon itself. So the goal of Broadcom is to continually, we ourselves want to innovate on this API. We want you as the community to innovate on top of it. We'll continually expand it, and you should see many more applications, not just FBOSS or SII that are running on top of it. The last slide, just so you've got some details if you do want to go and get it. This is the URL that you can get OpenNSL from. Like I say, do you remember there's two branches on there? The main branch is 6.4. That's not the FBOSS version. That's got more in it. There's a branch called 6.3 that you download to get the FBOSS version. You can compile that with all of the code that Adam mentioned, and you should be able to get a running system after a little bit of perseverance, and actually run that on wedge hardware or when that becomes available. So how are we making this open source when I'm talking about the SDK being proprietary? So with all of the include files that you need to compile with OpenNSL, all of the documentation, there's examples as well, are all there on GitHub. But the SDK itself is in the underneath, the southbound layer is in binary form. We support a number of platforms, and we're willing to add to those platforms as well. But from the start, it's clearly wedge. There's interface master support and the support for our switch verification kits and SDKs. It's very simple to add support for other platforms. But even as it is now, you can write your own applications on top of OpenNSL. It doesn't have to be just FBOSS. you can create your own applications, file against these platforms, we'll add more platforms over time. And it's all on a Apache 2.0 license. That's all I wanted to say about OpenNSL in this session. If you want to come and have a look at the actual APIs and play around with it, I encourage you to go up to the hackathon in 210E, those who can. And we've got our colleague up there, Rajesh Patula. He'll run you through any level of detail that you'd like to see on it. So, I wanted to make sure we saved enough time at the end. You've all been very patient. Nobody's asked questions throughout this conference so far. So I want to make sure you get the time to ask away.
Do we have any questions from the audience? Yes.
So I'm getting different information from up in the hackathon, but how supported is layer 3?
So for layer 3, so like the FBOSS agents provides APIs for adding or moving routes. We're using it as a full layer 3 switch. We do unicast only, so there's no multicast support in the FBOSS agent. But if you have anything that wants to talk forever to the agent and say add this route or move this route, it is up to that external thing to sort of, if you had sort of competing protocols or anything, to sort of isolate that into a synchronized RIB ahead of time.
I'm just more trying to clarify the OpenNSL.
So from the OpenNSL viewpoint, obviously we support what Adam just said, but also in the SAI demo coming up, you'll see layer 3 routing with ECMP. That's all sitting on top of OpenNSL as well. So I believe there's enough capability for you to do a wide range of layer 3 things. Is everything there that's in the SDK? I honestly couldn't answer that right now, but there's no reason why we can't add to what we have if there's features missing.
Hey Adam, that's Darren from Microsoft. Can you explain the design decisions you made for FBOSS agent, like contrast with, say, Cumulus Linux and using the Linux kernel, and why you decided to use FBOSS?
Sure. We have a couple documents inside. If you download the repository from GitHub, there's a directory of FBOSS agent doc. They're a little bit old at this point, but we have some documents sort of explaining why we went the way we went. So I can talk about some of our design decisions, but I sort of want to preface this with a caveat of like, I don't want to say that all of our design decisions are necessarily correct or anything. This is the first time we'd ever built a switch. So there's definitely things at this point where I'm like, oh, it'd be nice to go back and refactor some of this. But we have some decisions about how we design stuff. So inside the FBOSS code, we've got the sort of our central state object. So when we first started, we weren't sure sort of what sort of hardware we would want to support. Would we want to support like single chip systems only, multi-chip systems, whatnot? We're like, well, we've got a bunch of code that sort of shouldn't care about the topology of the system. It's just like, I've got a bunch of ports, I want to do some stuff. And so we've got a bunch of code that's sort of independent of the switch topology there, and we've got, which right now we call sort of like the SW switch, the software switch code, and there's a class called the HW switch, the hardware switch. And the theory there is that the hardware switch just exposes a bunch of ports. The software code doesn't really care about, how that's implemented in hardware. And so if you look at the difference between our wedge platform and our SIM platform is just a different hardware switch implementation that doesn't actually have a real hardware switch there. So we have these two sort of high-level APIs. This is a lot higher level API than if you look at sort of SI. And so we have this state object, and the state sort of encapsulates everything that the hardware switch object needs to know to program the hardware. So it encapsulates our VLANs, routes, port configuration, that sort of stuff. And we have this copy on write mechanism for this state tree. So you have your existing state tree. Whenever you want to make a change, you make a copy of the node you want to change and all those parents, and now you have this new tree that's almost identical to the old one and uses the same objects, but has this new state. And then our only API into this hardware switch is like, I changed something. Here's my old state, my new state, and you figure out what changed. This is nice from a software perspective. It's complicated for the hardware switch to implement. But the main reason we went this way is because, like I mentioned earlier, it was really important to us to make sure we could deploy our code every week inside Facebook. And we don't have redundant switches at the top of the rack. We only have a single switch at the top of every rack. And so we need to make sure we can deploy new code, like completely non-disruptively, not dropping any packets. And most of our application teams and our service teams have really good monitoring, which has actually really been very helpful for us. Because if we deploy our code and we deploy it to like lots of switches, we can tell right away, like, oh, that deployment over there, like we were dropping packets for like a really short amount of time. So this design decision of going with the state tree mechanism was mostly about making sure we could support graceful restart. We want to be able to have our process die and then start a new process. And the new process then sort of figures out like what state is the switch in, what state is the hardware in, and what state do I want it to be in. So the state tree mechanism is designed to support that. Of like the process starts, goes and looks at the hardware, and it's like the hardware is in this state, and looks at this config file and says, I want it to be in this state. And now I have to figure out how to get from here to there somehow. And so we were a little bit concerned that if we only did this like once a week during our pushes, that there might be bugs that we don't find because it doesn't happen very often. And so we're like, we want this to be the like way we do updates all the time. And so if we do updates this way all the time, like we'll find the bugs there. So that was sort of our main thought process around that. And there's a design document in there sort of explaining that. But there are some things that we might refactor in the future.
Okay, we have time for only one more question, and we'll move on to the other area.
Is open network supported in this architecture? And if not, it is to be supported. Where is it better to support? Is it at open MSL electron level or at the impact? Basically, where the tables goes.
So you can leverage either. I mean, there's plenty of good stuff that's been done in FBOSS, obviously. And if that suits your network environment, then maybe you want to innovate on top of FBOSS. If you have your own specialized environment, just like Facebook does, maybe you have something else that you have different ideas for how you control patching, and you can implement directly on top of an NSL. I think it's your choice really, and it depends on the flavor of your project. Adam, do you want to add anything?
Okay, that sounds good.
Cool, thank you. I realized we didn't get to, there's like 5 or 6 people that had hands still. If you don't mind, if you're on the IRC, you can start asking those questions on IRC, or even bring these issues on the mailing list, and then we can continue this discussion. Because this is just the tip of the iceberg, and we just gotta keep on trucking with networking.
All right, maybe thanks again to Adam and Simon. So there are a bunch of folks sitting in the standing in the back. There are plenty of seats up here while the next speakers get ready and mics. So plenty of seats here, plenty of seats here. So please come on in. You don't have to stand up the whole time.
Yeah, don't worry, you won't be on the camera.
If you want to do the demo, you might want to move closer to the screen.
Yeah, if you want to see, is it a video or kind of working or?
It's going to be a video that you can see here on the screen.
Yeah.
But the text is small enough, you might want to move closer to the screen.
If you really want details on the demo, move closer. Don't be shy. Come on up. So yeah, so continuing the software theme, right? We have FBOSS and OpenNSL. We've got the folks, Microsoft, Dell, Broadcom, Mellanox, going over the SAI. Another one of the software projects.
Hello, everyone. My name is Guohan Lu. I'm from Microsoft Azure Networking team. So I'm going to talk about this switch abstract interface, which allows user to program different ASICs through a unified API. This is a joint work with Mellanox, Dell, and Broadcom. So first, we're going to ask our contributors to present their view and perspective on this side project. So first, we're going to ask Adam Richard from Mellanox Technology to present their view on this side project.
He's kind of shy.
That does not look like Adam.
No, I'm not Adam. So this is a little bit of surprise. So yeah, so basically, as many of the faces are familiar, we've been joining the OCP networking for I think it was October 13 was the first time that we joined. And we presented there the aspect of opening interfaces and opening platform. And I think opening means the ability to select, the ability to choose everything. And then if all the interfaces are open, we can then demonstrate an ecosystem of building a system and environment. So basically what we see here, right? So basically what we can see here is we see that the interfaces or openness should be at all levels. So we started in this community of opening the switch hardware, and then we're starting to climb up. And starting to climb up, we have the ability to have systems with the selection of CPUs, then have open drivers, and Mellanox are working again with the Linux community to have drivers at the Linux level as well. Then on top of that, if we continue to move up, you have open APIs. Mellanox has, I congratulate Broadcom on their opening their a layer on their SDK. Mellanox has opened the APIs, I think we did the OCP last year, exactly. And then on top of that, we need to have the ability to build an ecosystem of protocol stacks. And for this, we are happily joining this community of building a unified layer on top of each vendor's SDK API in order to create an ecosystem of protocol stacks to be able to run and be hardware agnostic and provide, instead of rewriting the entire protocol stack hardware abstraction layer for each hardware, to have the ability to only innovate on those small parts that differentiate between one hardware and the other. So our platforms are already integrated on our PowerPC and our x86 with ONI. We provide, together with our OCP boxes, we provide ONI and SCI integrated as part of it. And it runs with our SDK and as open source, so every application can write its own code and glue it to the SCI, or can glue it to the SDK API and publish it as well.
So next will be the Sanjay from Dell Corporation.
Hi, so Dell is very excited to be part of this side demo. We believe a truly working code and an interop such as this is the best way to promote and spec and take it towards production. Dell has been Dell Open Networking has been a proponent of open systems, and with our Dash ON platforms, we have been putting ONI at the installers and supporting you, the customers, with a variety of network operating systems to be loaded on the same hardware. Those network operating systems can either come from one of our partners or can come from Dell's own OS itself. So that was the phase one of OCP's disaggregation architecture. What is really exciting about today's demo and what we have been working in SAR and other areas is the phase two of disaggregation. As Omar mentioned in his session today, the whole black box has been broken down into individual layers of that network operating system. So you now get a bunch of libraries, bunch of protocol stacks, bunch of forwarding drivers. Each could be totally disaggregated, coming from different vendors, either open source or otherwise, and can interoperate with each other using very well-defined APIs. So SAI forms the first but very important aspect of such an open ecosystem where the APIs are well constructed, and as you will see in the demo, we have a bunch of stacks and a bunch of suppliers, producers, as well as consumers into a consistent demo. So as I mentioned, this size is very important. Just one more point is with SAI now the application writers or the OS developers can focus truly on just the features that you want, and that can faster the feature velocity of any network operating system. So we are very happy to be part of this site.
Thank you. So next is Bengel from Broadcom.
Thank you. So just a few words about Broadcom's contribution to this effort. Firstly, thank you very much to Microsoft for their leadership in putting this little motley crew together. I thought we worked together well and put together something that I think we're pretty happy with. Obviously, the win for SAI is the ability to do that independent control application. We're very happy to enable the community to innovate in that space together. In terms of our involvement for this particular demo, we were fairly late to the game, I would say. We've been involved in the specification effort back in Q4 of last year, but it wasn't really until February of this year that we really started getting our hands dirty in terms of actually coming up with the code and implementation that we bring to this demo. So I thank Tushar from our team for being so quick in putting that whole thing together. As Simon has mentioned, Broadcom has rolled out 100 NSL in this particular event, and our SAI implementation is place to find. So, OpenNSL is an open library that allows to innovate on top of silicon and software and be able to open up the results of that innovation. We do plan on doing that with our SAI implementation. Until now, we've been fairly focused on getting ready for this demo, so there are some loose ends and rough edges we have to go back and resolve. Plus, of course, as we'll see, the actual functionality that we're going to demo today is a bit of a subset of the total SAI stack. But our plan is that we will be open sourcing the SAI code that sits above OpenNSL under the Apache 2 license, so that you guys can have at it and do what you want with it. We will continue to stay plugged into this community, work with extending the stack and help out on that as we can, and follow that up with implementation for scalable open source. And we're also going to be looking at some extensions such as maybe some implementation systems. So well done.
So next, I'm going to explain our perspective on this SAI project. So first, in our production network, we run this multi-vendor strategy across our networking stacks, from fiber optics to transfer servers to the switches. And switching ASIC is a central piece of this networking stack. So currently, each switch vendor provides their own SDK, who allows us to program on their ASICs. So there is no industry-wide standard for the programming interface for the switching ASICs. So from our perspective, we want a unified interface that allows us to build one program and program across the different ASICs. So with this unified interface, they also protect the vendor IP on their hardware investment, so that they have the interface does not ask the vendor to open their SDK implementations, which can reveal their IP intellectual properties. On the other hand, when we build these side APIs, we build it to very extensible so that the vendors can expose their new hardware features via the side extensions, so that each vendor, when they have new hardware features, they can have their own extensions to allow the applications to use their new hardware features through the extension APIs. So, however, in our current switch software stack, there is an important missing step, which is how we actually program the ASICs is not available to the open source community, which is mainly because the vendor SDKs usually have this software license agreement and a non-disclosure agreement, which does not allow us to open source those switch control software. So with this unified APIs, then we as a community can build these control softwares and be able to build together to have a very consistent and stable control plan softwares that is running on these open network switches. So then, after we have this stable and consistent softwares, then we can shift our focus, more focus on the more advanced SDK applications, which uses new hardware features that is available on these switches, and really to improve our data center network operations, efficiencies, and reliabilities. And this will be a big step towards open networking software. So next, I'm going to describe our demo setup. So we have built a small testbed multiple vendor switches. This is a test lab back in our Redmond. So we have under this monitor, you will see 4 switches, and then beside the monitor, there are 2 hosts. So next, I'm going to describe this setup for each of the 4 switches to describe their usage scenarios that they represent. So the first switch, switch A, is a Broadcom Trident 2 based switch, which has Dell implementation of the side and Dell applications that is running on the side. So the second switch, B, is also a Broadcom ASIC-based switch that with a Dell implementation of side and the Microsoft applications that is running on the side. Then we have this switch C, which has a Broadcom implementation of the side and the Microsoft applications running on the side. And the last, we have this switch D, which is Mellog's switch X2 based ASIC with Mellog's implementation of side and our Microsoft application is running at. So as you can see, for switch B, C, D, we have same applications running on different switch configurations. Also, as you can see, for switch A, we have different applications that is running on the same side implementation interface. So we wired these 4 switches through a 2-layer cloud network. This is to emulate our production settings. The top 2 switches are the leaf switches, and the middle 2 switches are the core switches. Through these core switches, we have 2 hosts that are connected to these core switches. And then on each of the core switches, you will see a /24 subnet, which the host lives in. Then all these 4 switches are talking through eBGP protocol, and the Tor switches are advertising the Tor subnet to each other, so that the 2 hosts can talk to each other. So next, I'm going to work give a walkthrough on the demo. We're going to show on this demo. So first, we will show your detailed configurations on a leaf switch A and on a Tor switch C. After that, we have set up all the configuration has been set up. So then we are going to do a ping from host A to host B to demonstrate the data plane connectivity. After that, we're going to use iPerf to generate the parallel TCP connections from host A to host B. And these parallel TCP connections will spread to both two leaf switches, so we can demonstrate the ECMP for this topology. So the next step, we will shut down the interface between the switch A and the switch D. Once the interface goes down, then the switch A will withdraw the routes, so that the switch C will only send all its traffic to leaf B. Then the next step, we will bring back the link between A and D, so that you will see the traffic gets redistributed through both switch A and switch B. So the final step, we will show the routing table on switch D, and we will also add a route using commands. So, and show the logs, and you will see that actually the application is using the side API to install the routes into the ASIC. So, so one more thing is that we also, our contributor manlogs also bring up live box in their demo booths. So if you want to see the live experience live box, you can go to their booth and to see the live demo. So next, we have recorded this demo video last week, March the 5th, and I'm going to play this video to show all the steps that I just described.
Hello and welcome to the OCP side demo. This is Kamala Subramaniam from Microsoft, and with me I have Guhon Liu, also from Microsoft, who is driving this entire demo. For the configuration, shown here are the 4 switches configured. The top 2 are the leaves in our class topology, and the bottom 2 are the Tors in our class topology. The top left switch is switch A. The top right switch is switch B. The bottom left is switch C, and the bottom right is switch D. We will now look at a detailed config of 1 leaf and 1 Tor switch. Let us now take a look at a detailed configuration of a leaf switch, switch A as an example. We have 2 interfaces with front panel ports connecting to 2 Tors each, and each interface has peer-to-peer IP address config. This switch also has a BGP router setup. It has 2 eBGP neighbors, which are the 2 Tors, namely switches C and switch D. Now we will show the BGP neighbors of A as C and D. We can also see the host A and host B advertised routes. Moving on to take a look at switch C, which is a Tor switch. We will first issue a show LLDP command to look at its neighbors. This is an example of show LLDP on switch C. This shows LLDP neighbors as 2 leaves, switches A and B. Now we will look at the BGP neighbors on switch C as well. This shows the BGP neighbors of C as switches A and B. Now that everything has been set up, let us try to ping host B from host A. We will now demonstrate ECMP. We have set up the iPerf server on host B. The iPerf client is on host A. The iPerf command will set up 16 parallel TCP connections that will be distributed across the 2 leaf nodes. Now we will issue the iPerf command on host A. Now we are going to go back to our tool, which is to switch C. Here we have an application running periodically that uses the SCI API to collect the port statistics. Here we see that the traffic is distributed across the 2 uplinks. Now we are moving to our leaf switch A, and we are going to bring down the link between switches A and D. Now, moving back to the tool, which is switch C, and polling the stats again, we see that all the traffic is hopped on from switch A to switch B. Now we will move back to our leaf switch A and bring the link between switches A and D up again. Moving back to the tool, that is switch C, we are waiting to relearn the routes on switch C and poll the stats again. We are now showing that the route tables have relearned the ECMP route on switch C. Let us poll the stats again. Looking at the stats, we observe now that the traffic is distributed across the 2 switches again. This wraps up our ECMP demonstration. We will now move to demonstrate another example, which is that of creating a route. For this, we will use switch D, which is a door, and we will take a look at its routing table. This is how it looks like. Now we will add a route to the store. We will now take a look at the route table in the kernel again. And as you can see, the newly installed route is found in the kernel. Now, let us move on to demonstrate another aspect of the SCI, which is logging, to ensure that the previous example's added route has been used by the SCI calls to program the ASIC. The SCI implementations have debug logs for every SCI API call, and we will show a detailed example of this output on switch D. This is how it looks like. You can see that it has called some of the SCI APIs like Mellanox create route. This is in fact the Mellanox implementation of the SCI call create route. Now, moving on to switch C, which is the Broadcom implementation, And looking at the logs here, and comparing both the Broadcom and the Mellanox implementations, you can see that they have both implemented the SCI APIs. This wraps up our demonstration. Thank you so much for watching.
So now that ends our demo, so I'm good to take any questions.
Just for clarification, once again.
To make sure people are remote.
Yes, just for clarification. If Mellanox is implemented, you use the word implement Mellanox. And Dell implemented this. What's the commonality between these? I thought that Psi is the underlying API. Mellanox uses and Dell uses. That one.
I think Psi is the API that different ASIC vendors as well as system integrators, they can provide the implementations. The implementation can be based on the vendor's SDK, so that on the switch box you will have a Psi library which you can call into, and then to be able to control the ASICs. And different switch vendors or system integrators can provide that library to you, so they can use it.
I would like to add that I think that this is a valid question. Basically, if you have a API, then you have another API in between, what's the difference between implementing one API to another by two different vendors? I think the answer is to prove that there is no translation or some kind of logic behind it. If two different vendors go to implement a glue between the same layers, so and they end up in the same functionality, means that it's stateless. There is no logic there. It's simply mapping, no matter who it is for.
Did I answer your questions?
By the way, can you bring up the architecture diagram or the little Visio diagram just to show kind of your block size and kind of which was Dell, which was Mellanox? Perfect. All right, great. Thanks.
This one.
Actually, from reading your work, exact words that you have been using, I understood what is the state of implementation, but I am concluding that SAI is not that vendor independent. That is my conclusion.
SAI is not the vendor. It's not the vendor specific APIs. It's the unified API that is the same across different ASICs.
Can I maybe because I haven't, maybe my understanding of it, right? So there's three boxes, B, C, D, right? There's a Microsoft protocol stack, right? And I'm guessing it's the same Microsoft code, the protocol stack, that's calling the same SAI things right underneath that layer, right? So you see the top layer that says Microsoft Windows, or not Windows, but it's got the Microsoft logo, and then it's calling SAI underneath, right? So my assumption is your protocol stack code is the same across those three boxes, even though it's calling Broadcom and Mellanox underneath. So your code, Microsoft code, is identical. Top part of the SAI, the northbound part of the SAI is the same. The bottom part is vendor specific. It's the implementation toward Mellanox or Broadcom, but Microsoft code stays the same.
Yeah.
Is that correct? That's my understanding of it.
Yeah, that's correct. So we have the same source code. We just compile differently on different boxes against the Psi libraries and be able to link to them and run them on different boxes.
Hey, so this is Sunay here from Pluribus Network. I had a slightly tangential question. I get the Psi implementation is perfect, right? I mean, allows you to develop code across Broadcom and Intel and Mellanox and for you, right? So the part I was kind of curious is, are you guys looking to go into more of,
Because oftentimes it's very useful to orchestrate all the boxes together and what is called knock-on interface and all that, for lack of a better word. But if you can actually tie side to something like maybe a REST API where it becomes a kind of a put some code out there, pseudocode, and happy to contribute there. That allows you to anyone to go and say, I got a box, and sign in there. Here's the REST code. I can just go and manage the box. And by the way, there are some effort going on this. I was talking to Google friends. They have a full config project. And, I think
Can I interrupt a bit?
Yes,
So, sorry about that. So this Q&A session is mostly about this question is about the demo, and I think we'll follow up. We have a panel discussions, and we invite various contributors to here to be able to have a more general discussions on the side of the switch control plan softwares, those kind of things. And
So a quick question from the IRC group. Will the demo video be made available on the web?
Yeah.
Just because the fonts are a little hard to see.
Yes.
Okay, I'll respond to that and I'll pass this on.
And the logical follow-up question. Will the Microsoft demo stack be made available open source? Can you talk about what that is? And it looks a lot like a standard, we'll say, industry standard command line interface. Is that something you guys implemented yourself? Did you use Quagga? Anything you can talk about that would be.
So
we've escalated. I apologize.
So the management application that we're using here is in fact Quagga, and it's a simple management application to get out the break because it's a demo. And given the terms of the open source license on, we'd be happy to sort of the patches that we did. But we won't redistribute Quagga until it doesn't have that changing license.
Question we have with this administration. In terms of SAA APIs, how do you define the scope? Is it strictly for the test applications, or can I expect the SAA APIs to expand towards the transport because
I think we are working on different proposals to include more scenarios. We're starting with the data center scenarios. We have so by the way, so this demo is based on the latest 9.1 version of the site, and we have more proposals that's coming out. We include like lag features, also the mirroring features, the queues features. We have if you go to our GitHub, you will see there are many more proposals on site. So initially we're starting from this data center scenarios, and we'll gradually include more scenarios, so that because we want to have this community to build control softwares upon this site API, and be able to share and give us open, an important piece of this open switch stack, software stack.
I see. The thing is, if you expand it beyond providing tunneling and then BFD or Ethernet OAM things, is there a push to do that? Are you accepting contributions of somebody puts time on that? And how do you want to define the scope?
I think it's ultimately it's like the user defines the demands, like what the user needs, what the user wants to build, what the user needs from the APIs, and we're going to, and we have the proposals and the different vendors. They have resources to do the implementations on top of this on this part of the APIs. Then we will be able to have them available for the user.
Yeah, so with that, we're going to kind of transform this into like a panel discussion with all the major players. Before that, just want to introduce everyone to the networking group's own Cortana, quote unquote. And that's Kamala sitting right here. She was the voice of the demo and the voice of the other thing. No, she doesn't. She's shy. All right.
So it should be up here.
All right. So are they going to get Adam here, or are they going to get Aviad, or who's going to be?
You need a bigger table.
Oh yeah, so there was a question that was supposed to be for the panel that we said was an appropriate question. Yeah.
Where's Dave? I don't see Dave. Oh, he's there.
So we thought we'd have a little panel discussion here. There we go. We thought we'd have a little panel discussion here. So I'm Darren Lord from Microsoft. I'm going to chair the panel. We have a free discussion topic where each of the panels will speak to the topics, then we can ask questions and see where this goes. The idea is to have a conversation and a discussion. So I'd like to take a couple minutes for each of the panelists to introduce themselves and talk about what they do for just a minute.
Okay. So my name's Ben Gale. I work at Broadcom. I'm an architect on the software. I've been involved in SIA. I guess SIA, I keep saying. Been involved in SIA from a state level since probably Q3 of last year, and from the code level, as I said earlier. Happy to help out.
So currently we're colleagues. I'm Ben Spear in Mellanox. I'm from the software architecture. Been to Mellanox for 6 years and OCP. And working on SI, I think, from day one.
Hi, I'm Alan Webman. I'm in the business development team of Mellanox, and I'm focusing on technology. But also in my previous experience, I was running the switch design and silicon, firmware, and software at Mellanox. And I was also lucky to be one of the co-founders of Mellanox. I'm happy to be here.
My name is Li Huayuan. I work in the Azure network management team, responsible for the software development on the network management side, in the switch operating system and the side.
Hi, I'm Dave Maltz. I'm the dev lead for physical networks and Azure networking. So my job is making sure the networks get put together and actually work for Microsoft first and third-party applications.
I'm Sanjay Sane. I'm an architect at Dell Networking. So I'm part of the SI group for a while now, and I'm interested in, as part of Dell, both in producing as well as consuming of SI in networking applications.
And I'm Gavin Cato. I'm responsible for the network engineering team at Dell. Definitely a big advocate for SI. I think we've been involved, I would say, almost pre-day one. Really pushing for an implementation that allowed us to build the differentiation on top and focus our efforts on differentiation. So ecstatic.
Thanks, everybody. So the first topic for discussion is what are the use cases that you see for SI? What are users that you've talked to are going? How are they going to use SI? How is it going to benefit them? That adds value.
So yeah, I mean, I think this has been touched upon. So far we've talked about the big win here is the ability for the community to innovate by writing a control plane application in a silicon independent fashion. That's kind of a big win, and allied with our initiative around OpenNSL, which enables those contributions to be open sourced, firstly by us up to the SIA layer, and then by you guys beyond that. It kind of enables that ecosystem to innovate and to share, to move disaggregated model forwards. In terms of the use cases, obviously, Guhan has shown us, what Microsoft is doing. We've seen it from Dell. So that's very much the classic control plane development, much along the lines of similar use cases to what Adam's right for Facebook. We expect to see a lot more of that. Plus, as I said earlier, with Broadcom, we're also looking to offer some differentiation in the vendor extensions of SAI to allow some of our other differentiation features to be exposed and exploited as well in a relatively unencumbered licensing environment.
We'll take questions after everyone gets a chance to say their.
I think the same is, for example, in the executive track that size widely discussed. I don't think there's a lot that can say that will be new out of the use cases. But I still would like to say, maybe state the obvious and not repeat what others said, and then give the personal touch of how we see it from the network side and how it's beneficial for us and our customers. Or start with the separation between software and hardware. I think makes it that you can optimize your solution, having a chosen software and a chosen platform of your wish, not getting tied to legacy. Not having tied, if you have software already implemented on one device, doesn't mean that the next generation you will choose a different platform. I think that's exactly what standard API allows you to do, is to shift between generation and to choose what is optimized for you today and not what's right for you in the past and maybe not going to be right for you in the future. And from analog side, I can say that we have two kinds of models that we sell our silicon switches. One is a complete turnkey solution with our own Linux OS, and one is selling silicon and hardware based on SDK. I think there's for us, and me from the background, that we have a very best class silicon, but when you don't sell to customers, so there's two versions of what you hear. First, maybe we are missing a piece of software, and this is kind of frustrates a customer that want to use us, but we don't have it in the software today. It takes a while to build up a full solution, especially if it's an enterprise solution. And on the other hand, when they want to implement their own software on top of our SDK, it's every company thinks twice before they do that effort. Having a standard API allows you to do it once, and then you'll be able to shift between different vendors, choose different software. Is it homegrown or customized or commercialized version? And to choose, as I said, in every generation, the optimized solution for you.
At Microsoft, we see ourselves as operators in the network, and it's really important for the customers that we house and host on our network that they have very high availability. We found that one of the greatest causes of lifeside impact is software bugs, and for us, we invest a lot of energy and work in driving bugs out of our software stack, and we see SAI as a way of making sure that once we fix the bug, that work can be preserved and we can take that forward as lots of innovation happens in the network space. We can take the same software with the same set of bug fixes in it across multiple versions of the same ASIC, potentially new ASIC platforms as we need to, thereby not have to refix the same problems again and not put our customers through repeats of the same lifecycle.
Yeah, so from Dell's perspective, I touched on a little bit. Our idea is to focus in terms of differentiation. To the extent that we're spending a lot of time integrating ASICs and working on the challenges of integrating new ASICs and taking advantage of the capabilities of those ASICs, but having to repeat that process as we look at different ASICs targeted particular market segments, what we find is that that's a huge amount of effort. If we can take that effort and really focus it in on our customer problems and the challenges that they're trying, we believe that we can raise it to an application level and look and take advantage of the hardware and the silicon that's available on the market, bring that to market quickly, rather than turning around and saying, hey, it's 12 to 18 months before we have something on the door. We want to be able to turn that quickly and turn that in 3 to 6 month effort. That's the value we see.
Questions?
So first, thanks. I think all this is great. I'm very positive before I ask my question. I know that Mellanox has their open Ethernet movement, Broadcom has their open MSL. What do you guys see as like the long-term value of SAI as, I as a consumer would love to use the API if it works for me, but at the same time, if that doesn't work for me, I can make my own API. And as those APIs become open, like the next level down, do we think 2 years from now, as all vendors have open APIs, that we'll need something? Or 5 years from now, or whatever that time.
So so from Dell's perspective, I don't want to implement multiple APIs. I think the challenge is it's a wasted effort for us. If we have a stack that we're working on for a data center market, we want it to work regardless of the silicon that's in it. So we can, well, yes, and well, so be great to have it if we had it without outside, but the reality is OpenSSL is not the same as Mellanox's API is not the same. So there's got to be convergence. If the convergence is SI, and that's what everybody's implementing to, and so there's a path from OpenSSL to SI, then we'll prefer the SI methodology because we can take SI and that becomes the standard.
Having this kind of standard, size is, like the guys mentioned, size is just one way of opening an API and having it standardized. I think what's important here is the standardization, not just the fact that opening an API. The fact that you see more and more vendors, and at the moment there are not many second vendors, but maybe in the future there will be more, using a specific API, this is what is the difference. Not specifically side, not specifically side as an implementation.
I want to think that Rob, your comment is should come from the ONL. From the ONL perspective, if you want to build an ONL, now ONL is about the ability to have a distribution that works on top, which is OCP, and OCP is basically hardware agnostic, right? Everybody is submitting their contributions to OCP. Now, if from ONL perspective, Big Switch wants to collaborate and with multiple vendors, you need to have some kind of a legacy APIs, otherwise you're tied to specific interfaces for either Broadcom, Mellanox, or whoever provides their solution. So, like size should be an enabler for open source distributions such as that.
Can I add one more point? Is that when we try to work on the side, right, we try to be network operation centric instead of being ASIC centric, right? So a lot of SDP expose a lot of ASIC details. You probably know. Right? So there's going to be a lot of concerns actually of exposing the ASIC details because there's a lot of IP in it. Right? And I think that providing a side layer that explicitly go across multiple vendors, being not response kind of operational centric, not talking about ASIC too much, the table resource too much, is a good way of helping the ASIC vendors protect their IP as well.
Good. I have one question that didn't get answered. This is coming from Flavor Center, small company. One thing I wanted to add, I'm one of the few guys who come from several guys, right? So this is perfect, just keep going, don't worry about 50 different implementations. I mean, this is how it will come down. Get how it will happen. What is useful will get adopted, just put it on GitHub, and you know, you guys are big companies, so obviously, you can make it work with yourself. I'm sure people will find that. So I'm not worried about that. The question I asked earlier was that, you know, I think there needs to be something, the thing I'm dealing with is between Facebook and OpenFlow and OGL and you know, God knows all the things out there. I think people are looking for some collection of consequences from some place. I know you guys have your own basically, and what I was asking is REST seems to be very good way. Everyone got your consequences. We have our own. If we can actually put a REST API on top of the side, actually have fun with it. Right? So you guys looking to do that?
So let me take that. We presented this architecture sometime back, or 2 sessions back, Microsoft and us. So as part of that, we started taking some baby steps. Right? We started from bottom to top. As part of that, the SI is the first step, which basically extracts the hardware out and it's. But we fully understand and agree that there is a need for a higher level API, some sort of a state synchronization, perhaps of REST/3 or whatever call it data-centric APIs. That is the term we use. So there will be an effort immediately after this session. So perhaps for the next technical meeting, we should all gather back and kind of focus on what that high-level data-centric API is. Absolutely, absolutely.
Well,
and
you're welcome to
you
join
mentioned
us.
about REST and all, right? I just want to clarify. There are two things, right? One is about the actual API to kind of expose the verbs and transcripts that, but the other is the data models, which is what the application interface is with the resources. So OpenConfig is an example of kind of explaining what those data models are. We also need a set of data models as well as the actual text. Both of them, we see something coming up fast.
I think it's well said that Psi is a, exposing the hardware, the higher layer abstractions on top of it. I think Rob said it great before. The actions are preferred, right? The comments are appreciated. Come and build it, but it doesn't. This should be an enabler to help you move that common data API on top of any other hardware.
Okay, I have a very basic question. This is my first OCP summit, my first session. So I hope you forgive me for asking you a couple of dumb questions. First of all, I saw that slide in which Facebook is showing its controller talk to the servers. And I'm assuming that's through FBOSS. So I'm a little bit confused in terms of how the controller is leveraging the networking capabilities that it may have to improve the server performance. So, for instance, you could argue that you run Hive or you run some other big data, and the needs at different points in times are different. So there may be need for a different routing protocol to be implemented. So, for instance, how would the controller work with the servers? Implement that. If it is not the case, then what is the vision of FBOSS and Facebook? Where is it taking? The second question, please forgive me on that even more. OVS, Open vSwitch. One of the successes of the SDN has been the separation of the logical state from the physical state. That has become a success. It is a success today. The success of this model which you are talking is still in dispute. It isn't yet proven. You cannot for sure say that all the possible configurations of the switch would function. You can test, before you deploy them. So those are.
I would kind of put those. Some of those questions are probably a bit higher layer than scope, and maybe out of scope for size. And size is just that hardware abstraction layer. All these problems are things that Psi could perhaps help you solve with a common set of software that you can take around different platforms. But I put that sort of out of the scope of Psi.
And in the end, you also had a question about FBOSS controlling servers and all. You could just come up and meet up with the FBOSS team and the folks on Facebook afterwards. I mean, some of the SDN controller stuff and the OVS stuff, is a little bit, it's just at a different layer.
I'd like to take the time to go on to the next topic. We'll get in one last question on this topic, and we've got about 20 more minutes or so we can always come back, but I'm going to pick one more.
You're competing with free beer upstairs.
Yeah.
Just so that everyone knows.
You can we bring the beer down here?
So, quick question. So one question, in the discussion with Sai, you've mentioned a couple of times that it's vendor access. Spec doesn't look like. We've got stuff that in the chipsets that we'd like to expose next to it. How do we do that?
So if you look at the Psi API, basically it's a very simple API style. It's called a key and it's got a value. Right? So every object is comprised of a bunch of objects. Each object can be identified a key and a value. And we keep on adding the keys as attributes. We can keep on adding the tables, which are all extensive. So in the last summit we followed the research slides that kind of mention as to how one can add a new set of attributes. If that's a abstraction that you want to expose out of your ASIC, as a new attribute, send a patch in the GitHub, or as a new table along with the key. the API style is very, very similar and across all the tables.
Just add tables and
I mean, I will just say that vendor extensibility, I'm sure Melanox will say the thing is very important to the vendors, right? We don't want to be constrained by a very generic set of operations. We want the ability to expose the differentiation inside our silicon. So that's very important to us. So that's a big part of the thing.
Yeah, not only that I agree, I fully agree, and I must add, Psi doesn't come to replace any hardware acceleration API. The statement behind Psi or any legacy API means that for 90% of the protocol stacks, they are driven from IEEE, IETF, or market standards, right? And there is no need to invent or to have customer specifics for adding port to a VLAN. And that's basically what Psi is all about. It doesn't mean that hardware is supposed to look the same. You still get secret source, and there's still a strong business model of providing added values to our better hardware.
Well, okay, but from us writing the management stacks on top of these, one of the nice things that Psi brings is a language for doing introspection on the ASIC and the cable capabilities you have. Yes, there's this extra QoS functionality. Now I know how to use that. I'm going to go configure that, or the platform running on doesn't have that capability. So I'll either use some mitigation, or I'll tell the northbound controller, hey, I actually can't do that QoS operation for that platform. Makes it easier for enumerating. We have a very diverse, heterogeneous set of network switches out there today. We see that continuing into the future. It makes it easier for our controller to go and actually inventory what the capabilities of the ASICs are out there. So that's one benefit we get as an operator working together.
Maybe one, just to introduce myself, so I apologize for the delay. My name is Eli Karpolowski. For those of you who do not know me, I'm running the SDN and cloud ecosystem at Broadcom. And just to add to some points to my fellow colleagues here, basically when you're talking about extensions, one unique extension that we're introducing into the community is what we call the broad view instrumentation. I think it's a very interesting set of features that allows us to kind of enable the ecosystem to have a better visibility and monitoring into the fabric, especially in this open community. What we find is in many cases there's some, I will say, issues related or challenges related to how you map overlay to underlay in an, let's say, open stack environment. One of the things that we added in the latest generation of our silicon basically was to provide those in-depth enhanced capabilities of the monitoring and visibility. And those capabilities are an example of extensions that will be available through Psi and other projects that runs on top of our OpenSL project. One last thing, but of course, I mean, it's the better silicon.
Well, we don't need to say.
Okay, let's separate these two.
We love it. Well, let's close them in one room together and close the door and see what happens.
Oh, play poker, right?
There can only be one.
But then we would, close it in one room. We need to take the stronger guy.
So, next topic. So, what is coming next in Psi and in open network software? Where will we be in 1 or 2 years from now around the Psi and programming hardware?
Yeah, I mean, obviously from a feature perspective, I think some of that was already talked about. Today we have fairly basic switching and routing, and then you're going to see a lot of new features getting added over the next few months. But they're coming in thick and fast. Proposals, and I'm having a tough time keeping up with it. From a review perspective, we're seeing QoS, ACLs, a lot more monitoring features such as S-flow and mirroring, lags, yada yada yada. And I expect to see that continue. There's a hunger to add more features as quickly as possible. And I know that we're going to be running as fast as we can to try and keep up with that from an implementation point of view. So I expect that within 1 to 2 years time, we'll have a pretty broad feature set, and you guys will be able to do most of what you expect to be able to do on such a platform. The interesting thing for me is what's going to happen above that, right? In terms of the actual applications that get developed, get shared, the projects that are emerging. We're doing this to enable you guys to innovate and do something. protection of that. I'm very curious to see where all that goes.
I agree, and I would like, so briefly, I think that the first step would be to just complete opening the legacy hardware features and side. The next step would be to build an environment of product like top of site, doing verification and test and an ecosystem of be able to work on top of it, tools and CLI interfaces, etc. And I think taking site to the next level, I think it would be nice to have some kind of a simulator on top of a server that can take site and tailor it to a very known hardware like a table switch is called Linux. You can have an implementation of site configuring Linux, then have a server multiple mix, and to show that it's actually working and enable applications that wants to start on a server before they are ported to a hardware, to a real platform work. I think this might be a nice project in the community to have such an acceleration and build an environment on top of site. And I think that looking to the future, and we have discussed that some of that yesterday, we need to think what comes out of a box of a white label switch. When it comes to the customers, I think we should come and ship with some kind of a network operating system. I think either ONL or other distributions might be a candidate to start discussing in this community, and then adding on top of that might include an ecosystem of software all the way to the top level of readiness.
Just to add to that, we have kind of a cadence of 3 months. We have been putting out the release of every 3 months, and there are some features that we have proposed. So I heard some comments about when would tunneling come or when would other features come. So feel free to send patches or start putting your comments on the mailing list, and we'll start putting adding features. So that's the immediate timeline. We have a cadence, we'll have features, and I agree with most of the other comments. Tests are required, simulations are required, but more important that deployments are required. So if you are deploying an SI, tell us about your experiences, tell us what you like, what you don't like, and that kind of helps provide the feedback.
The only thing I'd add is actually just to highlight a comment that came up earlier, which is that what we were starting soon on that next layer, the control plane service APIs, the information model on top of side,
So I think also on a practical point, I think what I'm seeing happening is actually the completion of a certain operating system. I mean, we're going to focus on the top of rack layer and then change to in production test bed, that kind of scenario. Then hopefully we can share more feedback of what's actually the operational experience of running the software stack on top of side, what API is reliable, whether this implementation is fast in practice, or like what was the bad design and we actually shouldn't have done that kind of operational experience.
I think also, it would be interesting to see the ecosystem comes around, as mentioned, and more to that to see that not only like early adopters like Facebook and Microsoft are engaged technology, are adopting design and application about, but to see it also in the enterprise and the storage and so on in all the vertical market. And I think that's what we will see success. Inside when you see all those late adapters.
I agree. I think that one of the things that I want to echo here is the fact that the application level is very crucial in this stage of the project. I think if I need to relate to what Frank said in the keynote session this morning about also the chain supply, how you actually support, how you've been able to facilitate that with a real live application and projects that will become something that is, I will say, commercial available. Now, the good news is that we'll just, Camilla, I think you mentioned this morning, there's about 51 new contributions to the new spec. I think that's very impressive, and I really want to thank Microsoft and Dell for supporting this. I think it's a tremendous effort that was done in only 3 months, and to get to where we are today shows some of the respect and kind of an acknowledgement from the market, from the community, saying this is real, this is good. So we're kind of looking at this and seeing a bright future. But thank you very much for doing this.
Thanks for everyone's involvement. So I'd like open the floor for questions.
In terms of contribution, so can you walk me through what the contribution process looks like? So I think right now what's available is basically a header file, and I can supply patches to that, which is a nice way of describing what I want, but presumably what you'd like to have from is code. And some of you, I think, have open source implementations of this down to like the next level. How does this process work here? How can I know?
As of now, it's all about header files and .h code, and the demo that you saw was entirely based on exchanging just the .h files. So yes, code is important, but right now the code is implemented by the SDKs which are closed source. But as I'm saying that for setting up the abstractions and for setting up the API, just the .h files into GitHub is good enough to start. Now, as we get the simulation, as we get the software simulation platforms, as you get a reference platform and one of these SDKs, it proves that that works. But from an API perspective, all we have seen so far is purely based on the APIs.
So, Robin, in answer to that, I mean, I think in the near term, the onus on delivery of the actual implementation side is going to be mostly going to be on the paper, like ourselves and like no one else in others. As I said earlier, we do expect open source our implementation to the extent we can above the OpenMSL layer. At that point, obviously, there will then be code that you can go in and look at and improve and patch and contribute back if you wish. But we need to kind of get to that base level before I think we can go much beyond the contribution of the header file at the state level. So be patient, it will come.
Copyright notice at the top to speak held by everybody, and as you know, copyright is an API, and you put an API from products. But it's always a discipline.
I am not a lawyer. We use the header file that is a BSD Apache-like one that our lawyers provided, which does the classic trick of preserving rights, so it is a copyrighted file, but then granting, identifying the authors. So you can't sue anyone who was an author of it, but then granting rights to everyone to then revise, extend, do what they want with it without needing to necessarily release the source. So we did the classic BSD Apache style, but like I say,
you are a lawyer. If your lawyers are involved in it, I know, like from a Facebook perspective, and everyone else are doing. We had many lawyers looking at all of that header code and all of that. Right? So, but if you're part of it, it was fine, right? I'm assuming that we're not going to expose ourselves. So, but if anyone knows of any sort of guys as problems and stuff, addresses, don't say anything.
Last question.
I just wanted to touch upon this comments earlier on extensibility, testability, stuff like that. So I encourage you to come at 1 p.m. tomorrow. We're doing a talk on P4, the programming language for forwarding data things. So we have a demo to show you guys on how you can model the SAI pipeline, actually extend it, test it.
Actually, I had a question. Are there other vendors that we know of working with Psi? I mean, you just mentioned you all are working with Psi. Anyone else?
I think Huawei stepped out of the room, but I think they have something going on with that.
Absolutely. Is it P4 part of the Psi now?
P4 is actually a programming language, so it can be used to generate Psi.
Barefoot has a personality module that basically makes data that looks like Psi.
My question
Donated to Psi card.
or possibly to Psi card.
That I don't know.
So whatever we're going to show tomorrow, the P4 code, we are planning to open source it. I'm going to.
We just have a couple minutes. Are we ready to wrap up, or do we have?
We are there.
Okay, we're ready to wrap up.
The year is waiting.
So thanks, everyone.
Thank you all. Thanks to the side panels.
to thank all y'all for hanging out as long as y'all did. 57 minutes.